Well, I'm Sam Markell. I'm an extension plant pathologist at NDSU, and I've seen probably half of you, maybe more than half of you. I work on broadleaf crop diseases. So I work on sunflower, canola, dry bean, a lot on soybean, pulse crops. And sunflower is probably my favorite crop. I really like sunflower, and I know that some of the people in the industry cringe when the pathologist says, sunflower is my favorite crop. But there is a reason for it, right? There is. It is a really solid crop, but it's also one of the very few that we grow that is actually from North America. Okay? You know, we grow soybeans from China and wheat from the Fertile Crescent and all that. Sunflower is from here, and the reason I'm saying that is that it's really well adapted to here, but so are all the pathogens and insects because they were also from here. So when you're growing sunflower, disease management becomes a huge issue, all right? So I'm happy to talk about diseases, and I'm thinking that there's a couple things I want you to be able to remember today. I want you to be able to differentiate the stem diseases. Okay? There's lots of stem diseases around, but not all of them are important, and we can't manage all of them. So you have to be able to tell them apart. Okay? You don't want to waste your money on a fungicide, right? And if you pick a fungicide, you want to use the right one, right? You got to tell them apart. The second thing is I want you to be aware of rust. I am pretty concerned about rust next year, and I'll show you why. So if you can remember anything, it's to differentiate the stem diseases and be aware of rust. But is there anything else that you want to talk about in the next 20, 25 minutes?
Some of the heads I've seen the mushy brown stuff that I don't really know what is.
Oh yeah, well I've got some mushy brown heads too. Okay. Yep, we'll show you some of those. That's good.
Since I'm new to sunflowers. So.
Okay, all right. We'll talk about mushy brown heads. Anything else? Okay, so we're gonna walk through here. I'm gonna show you some stuff. I'm gonna need your help. People, anybody have a knife? Okay, good. You're gonna get to use it. That's good. You're gonna have to be careful, but you know. Before we do any of that, I want you to think about bears. Okay? I want you to think about bears. In North America, we've got 3 types of bears, right? One's not super important, dumpster diver, right? What bear is that? Black bear, okay? We have a disease in sunflowers called Phoma black stem that's small and black and doesn't do much, okay? I want you to think about the black bear and Phoma, okay? Same color, same size, same effect, dumpster diver. We don't care about it. What about a different bear? What kind of other bear we have here?
Grizzly bear?
Grizzlies, yeah, grizzlies are beasts, right? They're big, they're strong, you know, they'll take your lunch money and run, right? Well, they don't run probably, they just take it, right? We have a sunflower stem disease that causes big and brown lesions and causes major problems, just like a grizzly, okay? With the last bear, Arctic, hunt you down for 5 days and kill you, right? It's a polar bear. They're kind of white and cream colored, gigantic, just terrible. Well, sclerotinia causes giant white tan lesions and just shreds the plant. Okay, so if you're going to think about how to identify these, I want you to think bears. Black bear, grizzly bear, polar bear. Okay, got it? All right, so we're going to start. You got to come with me. You're going to make the camera crew mad. Who's got a knife? Okay.
Serrated blade, straight blade.
Okay, you just get one. Who else has a knife? Okay, let's see, which one do you want? Maybe that one. Anybody else? Okay, I'll give you that. Anybody else? No?
Yeah, I got one.
All right, let's see, find another lesion here. Yeah. Why don't you kind of keep an eye on that one? Okay, so don't cut anything yet, especially yourselves. No, none of you, here. That's not a knife. Here, this is a knife.
Wow, I'm sorry.
Actually, that might be a little dangerous, so you might want that one instead. All right, so before you do anything, you need to know how this disease works, all right? So the stem diseases in general, Phoma, Phomopsis, and to some degree sclerotinia, they don't start in the stem. They start in the leaf. So what happens is you have this residue here all over in the previous fields next to you, blowing around. They have spores that kick out. And the spores land on the leaves first. Then they go through the petiole, the infection goes through the petiole into the stem. And so when you see FOMA black stem, what you see is a small black lesion that's started from usually a dead leaf. Okay, you see other things on this plant, but when you see this small black lesion, it started from a leaf. Okay? So what I want you to do is take your knife and just kind of gently scrape off and tell me what you see underneath. Yeah, yeah. What do you see under there?
Green.
Perfectly green. Healthy, right? Right?
Mm-hmm. Yeah, it looks nice.
Yeah.
Not bad.
This is that dumpster diving black bear that doesn't do any damage, right? This lesion is usually superficial. There's some exceptions. Once in a while you get an insect driving it in and all that. But as a general rule, these small black lesions on the leaf don't cause damage. Now this happens to be the most common stem disease in North America. And it's also the most commonly confused with things that matter. Okay, so if you're in your field and you're looking around and you've got tons of these black lesions and you're like, oh my God, I'm going to have to deal with this next year, don't worry about it. It's not a problem. Rarely will it do anything, okay? And it's because it's so superficial, okay? The dumpster diving black bear, small black lesion. Make sense? All right, why don't you go ahead and just throw them over here and we'll take a look at the grizzly. Okay, so we've got another disease. This is Phomopsis stem canker. Okay, grizzlies are bigger, they're brown, they do a lot of damage. They work exactly the same way FOMA does. The infection starts in the leaf, goes through the petiole, gets into the stem, and when you see a lesion start to develop, it looks like this. Okay, it's coming in through this leaf, right? It's a brown lesion. Okay. Yeah? Now this is going to keep expanding to the point where maybe it's this big. But what happens is it destroys the center of the plant. Okay? It gets really squishy. We call it the thumb test. So if you're in class if class is the field and I say do a thumb test, go ahead and squeeze it. Okay? In the new lesions, you won't be able to depress it, but in the more advanced ones, you'll be able to depress it. There's just nothing left. And so when you get it early, you'll have plants with tiny little heads, because more or less it wilts. When you get it a little later, they'll lodge. If we have a 50, 60 mile an hour wind come through, you'll know if you had Phomopsis, because they'll be laying on the ground. Okay, so grab a couple of them, see what it feels like. From my right to my left, there's kind of a level of squishiness. Yep.
It's only half.
Yep, it's just barely starting to get squishy. I want you to feel it, it's important. So feel one that's kind of tight. You know, it's getting just a little squishy. When you get to the end, they're really soft. And obviously that one lodged in my hand, right?
Does it move up to the head?
It can. Okay. Unfortunately, it can. You tell the difference, right? Yeah. So some of these have that brown lesion or the black lesion on them too, right? You can get Phomopsis and FOMA and you can get Sclerotinia all in one. This is the one that we really want to look at. So I would ask you, if you're in your field right now this fall, go out and look for this. This will overwinter. And if you have a ton of it, you'll be at risk next year. Now, obviously the weather and everything has to line up and all that. So what do we do about this? Crop rotation is important, but nobody's growing sunflower on sunflower, I hope, right? The longer you get out, the better. That's true too, but genetics is really important. And so you have breeding that's done all over the world, but it's really important to do breeding here against the Phomopsis we have, because it's a little different when it's in Europe, right? the different species and things, different environments. So the more breeding you can do here, the more environments company, whatever company that is, will be able to select more resistant material. And most of the companies have been doing this almost 2 decades. There was a burn down epidemic in 2008, 2009, and there was a lot of breeding done after that. So the genetics are improving, okay? So if you know you're at Phomopsis risk, try to get a variety hybrid, that's not as sensitive, something that's more resistant. You're not gonna get like pure resistant, but get something less sensitive. The next thing is fungicides. So we've done about a decade of research on fungicides at NDSU, and we've worked with a couple other universities. We do have products that work pretty well on Phomopsis. The timing's a little tricky. We generally are around R1, so when you have budding, but not bloom, but budding, you see the canopies start to close, you got a lot of leaf tissue out there, it's early in the season, and there's a favorable environment in the microclimate. If you hit a fungicide on that part, you're going to be protecting some of the leaves. And remember, these guys, they go through the leaf to the petiole to the stem. You gotta protect the leaf. You're not going to spray a stem anyways, but if you did, it wouldn't matter because it's going through the petiole into the leaf. Make sense? It's dependent on water. So in a dry year with no rain, you're not going to see Phomopsis. In a really wet year, you're going to see a lot of it. So fungicides are like a Band-Aid. They'll help. They'll help, especially if you can time it up to a rainstorm, but that's pretty hard, right? Especially if you only have 1 or 2 rainstorms. Most of the time you don't, okay? Fungicides will help, but what I would ask you to do now is to think about going in your field. If you got a field, take a look and see what you got. If you've got a lot of Phoma, good. If you got a Phoma infection on that leaf, Phomopsis isn't going to infect it, right? That's okay. Phomopsis, you need to start thinking about managing it next year, okay? Questions about Phomopsis? Oh, great question. Yes, I forgot. So triazoles, Frac 3s, generally do not work well on Phomopsis. They work well on other things, but not Phomopsis. Tends to be more strobilurins, so the old headline quadris approach and the premixes work really pretty well. Some of the SDHIs, so the Frac 7s also work well. Okay, there's a range. It is notable too that the best class of action on this Phoma is Frac 7. Which is interesting, so you can manage both of these. You're just kind of throwing your money away on that one because it's not doing anything. Okay, we're gonna look at the polar bear. Oh, these are looking pretty tough. Okay, so this one is a monster. This one's a monster. And when you have particularly a cool, wet year, this polar bear will hunt you down, take your lunch money, and probably eat you as well, right? It's just really, really difficult. So there are a couple things we can do about it, but we are limited. But it is important to understand how it works because it's very different than these other two, at least to some degree. The first difference is that this is Sclerotinia, and this is the same Sclerotinia that hits soybean and dry bean and canola and any of your broadleaf weeds. It's the same exact pathogen. There's no even difference in races. It is the same. Whereas those guys are super specific. They're super specific to sunflower. Okay? You can rotate away from them a little bit. This one, broadleaf crops, they're sensitive. So how it works is right now in the season, these will be full of black sclerotia. That's the reproductive survival structure of this pathogen. Oh, yeah, there we go. Okay, so if you get Sclerotinia, you're going to have these black structures get produced. Okay? And there was tons of them, and they're just falling on the ground. These are really small. You can get a lot bigger than this. They look like rat droppings, right? So these things are going to be produced anywhere there's a lesion. This is going to get harvested. All these black things will drop in the ground. They're going to survive maybe up to a decade, right? They're really, really tough. So they're going to drop to the ground. If, let's say, somebody plants a different crop here, the first thing that's going to happen is the sclerotia in the spring are going to germinate, and they're going to grow little, we call them hyphae or mycelium, little white, fluffy, fuzzy growth in the soil. Okay? They're going to grow that, right? And if that comes into contact with the sunflower root, you will have infection right through the root. Okay? So if the roots come into contact with the sclerotia that's germinating, you're going to have a lesion right from the base of the stem. It's going to go right up the plant. That's the first way it causes infection. And you can see in this case, you can see that white kind of fluffy growth on this. You can see that this is like almost concentric rings whitening. That's classic white mold. That's why it's called white mold in soybeans and dry beans. It's that color. Okay, that's the first way. A little bit later in the season, the sclerotia will put out these little mushrooms. Okay, so they'll grow and they'll do their thing, but the mushrooms don't show up right away. Has anybody seen like fairy rings in the grass recently? Yeah, right? That fungi is living under the grass. The environment pops and it sends up all those mushrooms, often kind of like in a circle, right? It's the same sort of thing. Not quite perfect analogous, but same thing. So you start to see these little tiny mushrooms, like a pencil eraser size, really small, pop up from the sclerotia. Now when that happens, it'll send spores up. And the spores will blow around and they'll do their thing. But the one thing that's really interesting is they don't infect healthy green tissue. They don't. They need something that's dying or flower petals. So how many of you have grown like a soybean or a dry bean or something like that? Canola. Most of you, or most of you will if you haven't, right? We talk about spraying fungicides during bloom, right? That's not because of any reason except the spores need the flower petals to start the infection. We need to protect the plants at that point. Okay, so with sunflower, the same thing holds true with the infection. So as soon as the sunflowers start blooming, they'll drop little florets, the pretty flower combos come everywhere, the heads will get infected, the stems can get infected, and you can get infected through damaged leaves. And when you do get an infection through the leaves, you often see, you kind of see in this one, there's kind of these concentric rings of fungal growth as it's killing this plant. You see that? There's little white mold here, right? Little white fuzzy growth, and then it'll start to shred. With sclerotinia, managing it is tough. Okay, so you got this, you see a lot of it. The first thing you want to think about is what else is this going to do to my farm? Because you know your soybeans, canola, dry beans, whatever else you're growing that's a broadleaf is also sensitive to this. The good thing is that you can usually manage it a little bit better in soybeans and these other crops. There's a little bit more about genetic resistance. We know there's fungicides and they do work, unlike in sunflower. So if you're growing sunflower, you see sclerotinia, pay attention to managing it in your other crops, because that'll help. If you can manage it in soybeans, well, there's less sclerotia in the soil for your sunflowers, right? So lengthening your rotation and managing it in your rotation crops are both important. We just can't touch it with fungicides. We have tried and tried and tried, and we just can't do it. We cannot get consistent control. It's probably that they're so sensitive. It's probably that they can get infected from birth to death. It's just we cannot do it. It's very unfortunate. We've tried and we just can't get it.
So that best case scenario to get away from this is your rotation, stretch out that.
Yeah, I mean,
is there a magic?
the longer you get away from sclerotinia sensitive crops, the better. But that includes like almost every crop you rotate with, minus cereals and corn. So it's tricky. You know, you're not going to go sunflower and then 7 years of weeds. You know what I mean? You know what I mean. So managing it in those managing it in the crops you're rotating with is really important. That's kind of the point. So breeding for this has been going on for quite a while, and there have been quite a few improvements in the last 2 decades. And most of the resistance we get is from wilds. Yep, it is. And that's another thing that's nice about this being native to North America, this crop, is that most of the wild resistance is in our backyard, you know, as opposed to going hunting for wild lines in China or whatever. That is very, very nice. We have an advantage here.
Can the broom bristle effect, when it's that bad, is that only from the soil infection moving on up, or can it also happen from the top down?
It'll happen from the top down as well. Yep. And
how many weeks?
Development takes a little time. This is actually a pathogen we call a necrotroph. So it's
Yeah.
Halloween's coming up, horror films, necrotroph, eat dead flesh, all that, right? So once this starts to kill the plant, it'll start to digest it. And it's kind of like this slippery slope of the plant. Once that process starts, it'll continue to go and speed up. It's a matter of weeks, not months.
Does a hard frost stop that?
Yeah, questions about basically killing the plant. So it will continue to spread in dead tissue, but when the temperature drops, it slows a lot, and that's very helpful. Turn the leaf over. Okay? See all these black pustules? They were brown about 2 weeks ago. Now they're black. I am concerned about this one. I'm really concerned about this one for next year. So, kind of briefly, rust is one of the most economically important diseases we have. It's the only one I care about on the leaves, and you can manage it really well with a fungicide, but you got to get out and scout and find it. Okay, so this is an academic. If you have rust, we can do something about it. They've got good genetic resistance, but if you still get it, which it can happen, you got to get on it. Okay, we don't want this. So how this works is you have all these black pustules here. They're survival structures. They're the spores that will survive the winter. And unlike cereal rusts, this will survive in our climate, right? All you in school probably hear about the rust that kind of moves north along with harvesters and stuff. This is not that. This is different. This is a different beast, okay? This is very specific to sunflower, so it's not going to go to wheat, and wheat rust isn't going to come to sunflower. So these are going to survive the winter. In the spring, they're going to kick out some spores, and eventually they're going to form the little brown pustules, okay? They're little cinnamon brown pustules, same size as this. And every 7 to 10, maybe 14 days, they go through a cycle. And it is like the classic epidemic, right? It just will go through the roof. So what it needs is something that's free moisture, so fog, heavy dew, kind of warm, and you'll get this starting to cycle, okay? So we saw this 2 years ago. What kind of winter did we have last winter? Mild, warm and mild. Now it's blowing up on us in big numbers. So we've surveyed North Dakota, South Dakota, Minnesota, more or less 70 fields. 100% of the fields we've been have rust. Now it doesn't all look like this, but if we're not careful, it might next year. Because if we have another mild winter and we have this kind of load in the system, it's going to be a problem. Make sense? Okay, so what we do about rust. So we have lots of good fungicides. There's lots of fungicides that work on this. The key is to get the fungicides on at the right time. Typically, when you get the canopy closed, you'll see rust show up on the lower canopy. By the time you get to bloom, it'll be on the upper leaves. If you see it at bloom, you need to spray it. You'll be money ahead if you spray it. Because this kind of damage, we see 3, 5, maybe 700 pound yield loss if you see this sort of thing pop up. And it only needs to be about 1% severity at R5 for it to cycle through to do this. Okay? Lots of good fungicides out there. Strobilurins work really good, triazoles work good, some of the SDHIs work really good. That's FRAC 1137 if that's your language.